So welcome Vanchika, Atharva, Janvi, Kashish, Ritu, Khushi. Good afternoon, Prashant. Good afternoon, Om, Pranika, Aryan and Veer. Okay, I can see 2 new names today. How many of you are attending this lecture today or are new joinees? Okay, good afternoon. Perfect. So should we start? Type in yes to let me know so that we will start. Good afternoon. Yes. So which chapter were we studying? We had started with functions. We had previously studied search and relations chapter, after which we have seen permutations and combinations. And after that, we had jumped back to functions. As I said, functions is continuation of your sets and relations chapter. In this function chapter, we have already seen 2-3 lectures. In our first lecture, we have seen overview of what functions are. I have correlated function like a machine, where you will give some input, and upon giving input to a function machine, we'll get some output. The different kind of important functions which we have seen, or the important graphs of functions that we have seen are, one is constant function, then we have our logarithmic functions, we have exponential functions, we have piecewise functions such as step function, mod function, or greatest integer value. Mod function is also known as absolute value function. We have also seen what is a fractional value. Fractional value is also known as, what you can say, only the decimal parts you are going to check in it. Then we have also seen other functions such as trigonometric functions. So today we'll continue and we'll see some more examples. In yesterday's lecture, we have also seen some examples based on logarithmic functions. The important properties of logarithmic functions are log of a into b is log a plus log b. Second important property, log of a by b is log a minus log b. Third important property, log of a to the power b is b into log a. Long jump that b raised to power can come in the beginning. We have a change of base formula. What is change of base formula? Log of m to the base n can be written as log m upon log of n. So today we'll see functions, but more of their graphical representation. Earlier we have correlated functions with a machine. So today we'll correlate functions with diagrams. So let's start. Is my green screen visible to everyone?
Yes, sir.
Before starting functions, I'll just revise relations. We have seen different types of relations. Relations such as one-to-one relation, one-to-many relation, many-to-one relation, and many-to-many relation. In one-to-one relation, each element which is present in A is also mapped to other elements which are present in B. One-to-many, there can be multiple mappings. Many-to-one, from many functions or many terms which are present in your A, you'll get images which are present in B. And then you have many-to-many relations as well. So suppose consider this equation, y is equal to 3x plus 1. If instead of x, I put value of x is equal to 1, what would be value of y? I would get value of y is equal to 3 1 3 plus 1 4. So when x is equal to 1, value of y is equal to how much? 4. What if I put x is equal to 2? Value of y would be 3 2 6 plus 1 7. So can I say that this is like a machine, where if I'm giving some input, if I'm giving x is equal to 1 as my input to my machine, machine is going to perform operation of 3x plus 1 So if I'm giving 1 as input, what output I'm getting? I'm getting an output of 4. If I'm going to put in 2, I'm getting an output of 7. So if I'm putting 1 as my input value, in my output, which value I'm getting? 4. If I'm putting 2 as my input value, which output value am I getting? 7. If I put 3 as my input value, which value will I get? I'll get 3 3 is a 9 plus 1 10. So if 3 input is present, which value I'll get? I'll get a value of 10. As I said, domain is your values which you can put inside. So which values can you put in? Over here you can write 1, 2, 3, 1.5, minus 0. All the real values are possible. And this portion is your domain. And domain in this case is all the real numbers. So what is your domain? Which are the values that you can input in the machine? And what is your range? Range is all the outputs that can be possible due to your inputs. So which output values are possible? 4, 7, 10, and many more. So if I put 1.1 as my answer, maybe in that particular case, I'll get 5 also as my output. So even my range in this particular case could be from minus infinity to infinity. The numbers which have been mapped over here, 4, 7, and 10, are called as images. And the numbers over here, 1, 2, and 3, are called as pre-images. So what is a function? Function is when, if I make a change in x, there should be a change in y. If by making a change in x, my value of y changes, then I can say that y is a function of x. And I write it in this way. Y is a function of x. That means y is equal to f of x. Because if I'm changing value of x, there would be a change in my output value or change in my y value. What is the necessary condition for a relation to be a function? So first of all, as we have seen, which values do I need over here? I need all valid inputs. If I put in an invalid input, my machine won't process. For example, let us consider a root x machine. If I put in negative values in this machine, I'll get under root of a negative number, which is going to be imaginary, and hence my machine won't work. Therefore, for this function, root x to work, I need all my inputs as positive or 0. Therefore, my domain is in this particular case is going to be all values which are 0 or greater than 0. And if I'm putting 0 or greater than 0 values, what output will I get? I will get 0 or positive values only. Okay. Now, if this is a function where each element is mapped to every other element, I want to know whether this could be a function. So I have 1, 2, and 3. Here I have 4, 5, and 6. For 1, I'm getting value as 4. For 2, I'm getting value as 5. And I'm getting a value of 6. And for 3, I'm getting a value of 6. Now this is a function, but is this one a function? Yes or no? Let's check. If there is any equation which satisfies this, if I'm putting 1 into my machine, I'm getting 4 as my output. But if I'm putting 2 into my machine, I'm getting 2 outputs, 5 and 6. So the output is not in my hands. Output can be 5 or 6. do I want such a kind of machine where I don't know what my output is going to be? If I'm just putting in value of 2 and I'm getting output, it can be 5 or it can be 6. You are not going to use such kind of machine where you don't know the output. Therefore, this function or this machine is not going to accept this 2 as my input because it will produce 2 outputs. Therefore, this is not a function. The reason why it is not a function is because when you're putting in one value in the machine, you are getting 2 values, or the relation over here is 1 to many. If there is 1 to many relation, it is not a function. Also, it is not a function if the input value doesn't produce any output value. Suppose if I put in 1, I get a value of 4. I put in 2, I get a value of 5. I put in 3, but I don't get any output. So in this particular case, consider we have again a machine. If I'm putting in 1, I'm getting 4 as output. If I'm putting 2, I'm getting 5 as output. And if I'm putting in 3, I'm not getting any output. So will this machine accept this 3 as input? No. Because when you're putting in some value, you're not getting any output. So if there is any number which is present over here, which is not producing any output or not getting any image, then it is not a function. Let's revise. It is a function if each and every element in your domain has a mapping with each and every element in your range. It is not a function if one of the element in your domain region is not mapped. Also, it is not a function if there is one to many relation. That is, if one element in your domain produces 2 outputs, it is still not going to be a function. So the necessary condition is that it should produce 1:1 output. Okay, now let's see one more condition. 1, 2, and 3. Here I am having, say, suppose values of A, B, and C. When I'm putting in 1, I'm getting a value of A. If I'm putting in 2, I'm still getting a value of A. And if I'm putting in 3, I'm getting a value of C. Is this a function? Okay, let's see our conditions. What is the first condition to be a function? That each and every element over here should be mapped. So 1, 2, and 3, each one is mapped, each one has a partner. Okay, so first condition is satisfied. What is second condition? That there shouldn't be one to many relations. There is no one to many relation. When you're giving 1, you're getting A as output. When you're giving 2, you're getting A as output. So this is not one to many, it is many to one relation. So second condition is also satisfied, that there is no one to many relation. Therefore, I can say that it is a function. So what are the necessary conditions? Each of the element over here is mapped. And second, there is no one to many relation present. If many to one relation is present, that is okay. you can call that as a function. Is there any example of many to one relation which is a function? Yes. Best example would be a mod function. If you consider this function, y is equal to f of x, which is equal to mod of x. So y is a function of x. If I put in value of x is equal to 2, what would be value of y? Y would be value of mod of 2, which is also equal to 2. And if I put in value of x is equal to minus 2, what would be value of y? Mod of minus 2, which is again equal to 2. Therefore, if I draw a diagram over here, in my x, I'm having two values. X can be minus 2 or 2. In my y, I'm having one value, which is 2. If I'm giving minus 2 as input, I'm getting 2 as my output. If I'm giving 2 as my input, I'm still getting 2 as my output. So this is many to one relation. Many to one relation is allowed because each and every pre-image in your domain has an image, a unique image in your range. Therefore, this is a function. Now, say suppose there is a function f of x is equal to 3x plus 2. And you have to find value of f of 0. So what should be done in this case? Instead of x, you just have to substitute 0. You had x over here, but instead of x, you want 0. So this will be 3 into, instead of x, you are writing 0, which is equal to how much? 2. Suppose f of x is given as x square plus 3x plus 1. And I have to find value of f of sine x. So instead of x, what I want is sine x. So instead of writing x square, I will put in sine x, the whole square, plus 3 into x. Instead of writing x, I can write sine x, plus 1. Suppose there is another equation where f of x is equal to 3x square minus 4. And you have to find the value of f of 1 by 2. So what you are going to do, instead of writing x, you are going to write 1 by 2. What is 1 by 2 square? 1 by 4. So this will be 3 by 4 minus 4. Taking 4 as your LCM. That would be 3 minus 16 minus 13 by 4. Okay, so go through these examples. You have 30 seconds and you can ask any doubts. It's a bit involving. Type in your doubts if you have any doubts. Type in yes if you have understood so that I will proceed. we are definitely going to look at more examples so that this will be more and more clear. Okay, understood from Aditya, Payal, Rutu, Khushi, Om, Kashish. Perfect. So I'll move on then. Let's see a few examples so that you'll understand how to apply this. You have to find value of x if g of x is given as 0. First, g of x value is equal to 5x minus 6 by 7. So this function is given g of x is equal to 5x minus 6, and if you put or find out this value, the value is equal to 0. In which particular case? So what would be value of x to get g of x is equal to 0? So basically you just have to write this value is given g of x is equal to 0, and you have to find which value of x is going to satisfy that. So just equate with 0, 7 to other side 0, so 6 upon 5. So that is my answer. Next is g of x is given as 18 minus 2x square upon 7. So g of x is 0, which is equal to 18 minus 2x square by 7. Therefore I can say 7 to other side 0, just equate 2x square is equal to 18, 2 1s are 9s are x square is equal to 9, which means x is equal to plus or minus 3. Let's see next question. If f of x and g of x are equal, in that particular case I have to find value of x, and f of x and g of x values are given to me. X is equal to x raised to 4 plus 2x square, and g of x value is also given, which is equal to 11x square. Okay, simple. It's given that both of them are equal, so just equate them. X raised to 4 plus 2x square is equal to 11x square. Therefore, x raised to 4 is equal to 11 minus 2, that is 9x square. So this cancels out. X square is equal to 9. X is equal to plus or minus 3. Let's see next question. It is given that f of x is equal to 3 into 4 raised to x plus 1. You have to find value of f of minus 3. So simple, instead of x, just write minus 3. So that would be 3 into 4 raised to minus 3 plus 1, that is minus 2. So 4 raised to minus 2 means 1 upon 16. 4 square is 16 and minus sign is there. So I'll write that in denominator. So 4 raised to minus 2 is 1 upon 16. So answer is equal to how much? 3 by 16. Next. F of x is given as 2 into mod of x plus 3x. I have to find value of f of 2 and I have to find value of f of minus 5. So f of 2 instead of x, just write 2. So this will be 2 mod of, instead of x we are writing 2 plus 3 into 2. So 2 into mod of 2. What is mod 2? 2. So 2 to the 4 plus 3 to the 6. 4 plus 6, 10. Second case, instead of x we are writing minus 5. So this would be 2 mod minus 5 plus 3 into minus 5, which is equal to What is mod of minus 5? 5. Remember, mod is your distance, absolute value. Mod of 3, 3. Mod of minus 3 is also 3. Mod of 5, 5. Mod of minus 5 is again 5. Plus 3 into minus 5, that's minus 15. So 10 minus 15 is minus of 5. Okay. Now let us say f of x is given as x plus 1. And I have to find f of x square. So what would be value of f of x square? Instead of x, I want x square. So what I will do, instead of writing x over here, I'll write x square. The plus 1 term is as it is. So f of x square would be x square plus 1. What if I have to find value of f of x plus 1? So in this particular case, what you're going to do, instead of writing x, just write x plus 1. So instead of writing this x, I will write x plus 1. Plus 1 term is as it is. So that is equal to how much? X plus 1 means x plus 2. Next, I have to find value of f of 3x minus 1. Instead of writing x, just write 3x minus 1. So instead of writing x, I will write 3x minus 1. Plus 1 term is as it is, which is equal to minus 1 plus 1 cancels out, 3x. So copy this down. We'll see more questions. Let me know if you have understood this. So type in yes if you have understood. Okay, Muzammil, AVM, Yogita have said understood to previous slides. Okay, Aditya Singh got it. Om has understood. Perfect. Rutu and Muzammil are also saying that they got it. Okay, so Rushikesh, Pranika, Yogita, Prerna, Payal have also understood. Perfect then. I'll move to next slide. Now, if f of x is equal to x plus 1 and g of x is equal to 3x, I have to find value of fog. So what is fog? Fog means f of g of x. In a previous question, we have seen if you want f of 3x, what I will do, instead of writing x, I'll just write 3x. If I want f of sine x, instead of x, I'll just write sine x. I'll replace x with the term that I want. Now in this particular case, instead of x, what do I want? I want fog. Fog means f of g of x. So instead of x, I want g of x. Therefore, I can say this term f of g of x is equal to, instead of this x, g of x. And what is g of x? G of x is 3x. So instead of writing x, I'm going to write 3x. So that would be 3x. This plus 1 term would be as it is. So f of g of x is equal to 3x plus 1. Okay, we'll see one more example. F of x is equal to x minus 1 upon x plus 2 and g of x is equal to 2x. Sorry, excuse me. I have to find value of fog, or fog means here f of g of x value. Instead of x, I want g of x terms. So what I will do, wherever I'm seeing x, instead of writing x, I'll write my g of x terms. And what is g of x given as 2x. So instead of x, I will write 2x. Numerator minus 1 as it is. Similarly in denominator, instead of x, I'll write 2x plus 2. And that is my answer. Now, suppose f of x is given as 3x square plus 1 plus 2x, and g of x is given as x minus 1. Again, in this particular case, I have to find value of fog or f of g of x. So what I'm going to do, 3. Instead of x, what I want is g of x. So instead of x, g of x terms, which is x minus 1. So instead of x, I will write x minus 1 the whole square plus 1 plus 2 into x. Instead of x, I have to write g of x terms, which is x minus 1. So that is equal to 3. A minus b the whole square is a square minus 2ab plus b square plus 1 plus 2x minus 2. Just simplify this. So that would be 3x square minus 6x plus 3 plus 2x minus 2 plus 1 is minus 1. So 3x square minus 6x plus 2x minus 4x, and 3 minus 1 is 2. So go through these 3 questions and solve this one. F of g is given as x square minus 9, and g of x is given as 2x plus 1. My question is find value of fog. Also, I want you to be more creative, and if you have really understood, find value of GOF, that is g of f of x. Okay, so let's start. You have 2 minutes to copy this down and solve this question. If you have any doubts, ask your doubts. If you need any help in a step, I can tell you. Okay, Atharva, f of y is equal to f of x means y is a function of x. Yes, Atharva. If you're saying y is equal to f of x, it means that it is a function of x. And even if you're saying y is equal to g of x, it still means it is a function of x. Why are we writing y is equal to f of x? Because function f, that is the standard notation. So you can use any other term. If you write y is equal to f of z, then that would mean that y is a function of z. If you write y is equal to f of theta, it means as you're changing theta, your value of y would change. So in that particular case, y would be a function of theta. So does that answer your doubt, Atharva, or do you want me to clarify something more on that? Others, I want you to solve. Perfect. Thank you. You have 1 minute remaining. Copy this down quickly and solve or find value of fog, and be more creative, find value of GOF as well. Okay, answer is 4x squared plus 4x minus 8. Let me see. Okay, I'll have to solve. Okay, Atharva, your answer is right. Khushi, did you get a mistake? It's not x plus 1. I have written 2x plus 1. Okay, Goff answer is also given. So how do you solve Goff? Instead of writing x, in this particular case, you'll write f of x values. So instead of writing 2x plus 1, you would write, instead of x, replace x with the function present, which is x square minus 9 plus 1. So that is 2x square minus 18 plus 1. That's minus 17. So correct answer. Rutu, you forgot about this 9. It is x square minus 9. So answer would be 4x square plus 4x plus 1 minus 9. Last 30 seconds. I want some more answers. We have 34 participants, so I'm expecting at least around 25 answers. If you are not able to solve, then ask where exactly you have stuck, which step you have not understood. Last 15 seconds, fast. Correct answer, Khushi. Okay, time's up. Let's see next question. F of x is equal to 3x plus 5 and g of x is equal to 6x minus 1. So what I want is, I want to find all the values. I want to find f of FOF. I want to find FOG. I want to find GOF, and I have to find GOG. So what does FOF means? It means this. What does FOG mean? We have seen earlier, GOF means G as a function of X, and GOG means G as a function of G itself. Okay, so let's go one by one. First, what I want is f of x, FOF. F of x value is given to me, which is 3x plus 5. But instead of x, what I want now, I want f of x. So simple. Instead of writing 3x, instead of writing x, what I'll write? I'll write f of x. And what is f of x? It is given as 3x plus 5. So I'll replace x with 3x plus 5. This remaining term plus 5 is as it is, so I'll write that. So my answer is equal to 3 3s are 9x plus 3 5s are 15 plus 5. So that is equal to 9x plus 20. Next, what I want is f of g of x, that is fog. Now, instead of x, what I want is g of x term. So 3 into x, instead of x, g of x term is this one, 6x minus 1 plus 5 as it is. So that would be 3 6 is 18, x minus 3 plus 5. 5 minus 3 is 2. So answer is 18x plus 2. Third, I want g of f of x. Now g of x equation is given to me, 6x minus 1. But instead of writing x, I want to write f of x term. Okay, so g of x equation is 6x minus 1. So 6 into x. But instead of x, what I want is f of x. And f of x is given, which is 3x plus 5. And g of x remaining equation is 6x minus 1. I have just replaced x with this term, f of x. So that is equal to 6 3s are 18, x plus 6 5s are 30, minus 1. So that is 18x minus 29 plus 29. Sorry. And fourth one, what I want is g of x. So 6 into, instead of x in this particular case, again I wanted g of x term. And what is g of x? G of x is given as 6x minus 1 minus 1. So that is 6 6 are 36x minus of 6 minus 1. Okay, I wrote the answer. It's minus 7. So 36x minus 7. Perfect. So go through this example. If you have any doubts, you can ask. We'll stop over here, and tomorrow we'll see a few more examples from functions. We'll try to cover up as much as possible from both your exercises, first and second. If possible, we'll finish up the chapter tomorrow itself, or else we can take one more lecture if required. So your homework is to practice as many questions as much as possible from your logarithmic type and the example categories that I have seen today. Tomorrow we'll see more of these examples. Okay, so thank you everyone. You know the drill. Type in yes if you understood. Type in no if you didn't get anything. 50% if you understood 50%. Any comments or feedback that you want, any doubts that you want to be solved. So understood from Parth, Atharva, yes, Siona, Prashant, Payal, Pranika, Kushi, Kashish, Prerna, Rishikesh. Enjoyed, interesting, examples were interesting. Thanks. Oh, missing, clearly understood. Okay, Prashant. You can cover the lecture. The lecture will be uploaded, or you can ask Tusha sir if you have missed a lecture. Asta Singh understood, Muzamil and Prashant. Perfect. Thank you. So thank you everyone. Have a good day. And study. Complete your as much as questions are possible from both of these exercises. See you tomorrow. Thank you.